All right, we're back with Saxon Algebra 2, and we are in Lesson 2. We're going to talk about negative exponents for a moment. Negative exponents cannot be understood. We've talked about this in Algebra 1. There's really no explanation. So what we can do is we can work around them. So when we say we have a exponent, 2 to the 3, right? We know that's 2 times 2 times 2. That's understandable. But when we have 2 to the negative 3, we go, huh? What's that mean? All right, so we have a workaround for that. And the workaround is to flip it. So we get rid of the question mark because we're smarter than that. And what we do is we take this negative sign off of the 3 and we flip this into a fraction. We put everything under 1 and give the exponent its positivity back. So this is what a negative exponent really means. It really means it is the reciprocal of this number here. So that being said, if I had this, then that would mean to flip it back. So then it would be 2 to the 3rd is what this would actually mean. So we want to get rid of the negatives so that our information is clear. And when you have a whole number and an exponent in a fraction, go ahead and solve it. 1 over 8. Okay, 2 times 2 times 2. And the same thing here. Go ahead and solve it. Don't leave it. All right? Whole numbers with exponents should always be solved. Variables with exponents, you really can't, so do your best. You can keep the exponent with variable, but when you have a whole number with a exponent, please solve that. That's entirely doable. All right, so the definition of x to the negative n equals 1 over x to the n. This is what you want to write down for negative. There's supposed to be an I there. Exponents. Negative exponents. That is what we have here. The definition of x to the negative n is 1 over x to the n. All right, so let's do example problem 2.1. Illustrate that. We have a series here that we're going to do. We have 1 and 3 to the negative 2. We have 3 to the negative 3. We have negative 3 to the negative 2. We have, let's see, what's the last one? How many is that? I see it. We have negative 3 to negative 2. That's why it confused me. And then we have negative 3 to the negative 3. All right, for this first one, it's pretty straightforward. We know we can just flip it back. So that equals 3 to the 2, which equals 9. Done. All right, this one is pretty straightforward too. We know we just need to flip it, so it's 1 and 3 to the 3, which means 1 over 27. Pretty straightforward. All right, so now we just have to think about the process. The negative is not attached to the 3. It's asking for the opposite of a positive 3. So we have a negative 2, so we need to flip this and leave the negative on the outside. So that's going to be a negative 1 over 3 to the 2nd. So it's going to be a negative 1/9, right? Now in this case, the negative is attached, so it stays with the negative 2. So we have 1 and a negative 3 to the 2. Well, that is 1 over 9, and it's positive because the negative was included. Okay? All right, now in this one, the negative is not included, so we have to do this part first, right? So that's going to be 1 over negative 3 to the 3rd, and then we're going to bring that negative in to the fraction. So it's a negative 1 over negative 3 to the 3rd, Negative 3 to the third is negative 27. And when you have a negative divided by a negative, that is a positive. So the answer is a positive 1 over 27. The two negatives cancel each other out. Okay? Awesome. So now we have answered all the possibilities with negative exponents and how they're included. So now we're going to talk about 2b, the product theorem for exponents. Let's clear the page, pause and take notes if you need to. This is section 2b. We remember that x squared simply means x times x. And if we think about it, we just put a number 1 here and we add them together. So that's really x 1 plus 1. So when we have the same base, we just add our exponents together. We remember that, right? And that also means that we can do something like this. We could say x squared times x3, which equals x 2 plus 3, which equals x to the 5th. As long as the base, the variable, is the same, we can do that. If they are being factored, if they're being multiplied by each other, then we can add the exponents for the same basis. And that is called the product theorem for exponents. And that's exactly what we have here. And it's illustrated. Let me write this out. The product rule for exponents simply says xm times xn, given that x are both the same variable, equals xm plus n. That's all you have to remember right here. And if you want to illustrate, if you want to include this as an illustration, you could do that, because sometimes having two letters is confusing. All right, so we have another theory that we need to look at. Well, first, before we do that, let's go ahead and do example 2.2. Example 2.2 is just going to be some simplification, some more of this right here. So we have x squared, y, x to the negative 5, y to the negative 4, x to the 5, and x to the 0. Who remembers what x to the 0 is? X to the 0 is 1. So we can cross him out from the very beginning. If you have x to the 0, you just chunk it. You don't even have to write it down. So now we have to deal with these. So we have x to the 2nd, x to the negative 5th. You keep the sign with the exponent, and x to the 5th, right? Now we have a y, and that's a y to the 1. And then we have a negative 4. So that would be y 1 minus 4. That's both of those. So now we just have to do the math. So 2 minus 5 plus 5, those cancel each other out. So it's going to be x squared. And we have y, 1 minus 4, well, that's y to the negative 3. We know that we take a negative exponent and flip it. So this is going to equal x squared over y to the 3rd. Okay? And we brought this negative to the bottom, to the denominator, to get rid of the negative on the exponent. And that's how you deal with that. All right, 2.3. We did this last year in Algebra 1, so you should remember that. We have some more of this. We have y to the negative 3, x to the 4, y to the 5, x to the negative 10. Let me see if I can actually write that better so you can see what I have. X to the negative 10. And that's all over y to the negative 6, x negative 3, y 10, x squared. All right, everybody who had Algebra 1 last year should have no problem with this. So remember, when we have exponents that are by themselves, we just stick a 1 to help us see that better. And we're going to just combine all of our y's first. So let's just do that over here. We have y1, y negative 3, that's going to be negative 2, negative 2 and a 5, that's going to be a 3. So we have y3, and we have an x. We have x to the 4 and x to the negative 10. All right, 4 and negative 10, that's going to be a negative 6, right? Let's look at the bottom. We have negative 6 for our y. Let's do y here. We have negative 6 and a positive 10. It's going to be a positive 4. And for our x, we have a negative 3 and a positive 2. That's going to be a negative 1. All right, so all we have to do for this is just to flip our negatives from one side to the other. So when we flip the x here down, we have y3, y4, x negative 1, positive 6. So that becomes y to the 3rd, y to the 4th, x to the 5th. And that's where we would stop. Okay? You wouldn't just swap places, because if you did that, you would have y 3rd over y 4th, and then that would be x and then x to the 6th. You wouldn't do that, because we want to factor, and we're still not done with this one because we can still factor some more. Okay, so you would take one of the x's out and leave that as x to the 5th. So we're going to do the same thing with our y's, and that'll be our final step. You've got 4 y's here, so if we took these 4 and brought them up, we would have 1 y left, and then we would have that'd be negative 1, so we'd have to bring him back down. So technically, I did that the wrong way. Technically, what we would have is 1 over yx5. That should be our answer. Let me see what the book says. Yeah, the book says that our answer is going to be y negative 1 x to the negative 5th. Or you could put it over this fraction and it would be accurate. Okay, this is the way I want to see it. Unless it says make sure all the factors are all the exponents are negative. If it says write them that way, then leave them like this. If it says all positive, then you need to write them like this. So it's going to be based on what the question asks, just like normal. All right, so let's go into the power theorem for exponents. We did this last year as well. If you need to pause and take notes, do so now. So our power theorem for exponents, if you remember from last year, power rule for exponents. Simply says that when you have x to some power to another power, you just multiply the powers. So to illustrate that, let's say we have x to the 2nd to the 3rd, we would end up with x to the 6th. The illustration of that is x squared times x squared times x squared. 2 plus 2 plus 2, that equals 2 plus 2 plus 2, which equals x to the 6th. Okay? That's the same thing we got here, we just multiplied. All right? So you're going to want to write this illustration down in your notebook. That's a for sure important note. Now there's also an extension rule, an extension of powers. And what we're going to do is, if we have x to the m, n to the, say, p, and all of this is to the z power, then you end up with x to the m z, n to the p z. So you multiply this exponent times every exponent inside the parenthesis. For instance, if we have x to the fourth times y to the third, and that's all to the second power, our answer would be x to the eighth, y to the sixth. Okay? All right, so that's another rule you want to write down and illustrate so you know how to handle that situation. All right, once you're through writing all of those down, then we are going to clear the page and we're going to do some sample problems in that. So sample 2.4 says to simplify, and I'm going to write that down for you real quick. All right, through the magic of video, I have written it all down for you. Why don't you go ahead and pause and write down the problem, and then we can work it together. If not, you're going to be playing catch up. All right, I'm going to assume you wrote it down. So for the first step, we use the power theorem in both the numerator and the denominator, and we get this. Right? So we have x times, and this would give us -6, and y times, this gives us -3, this gives us +6, right? Same thing here, 2 and 3 is 6, then we have the -3, and 2 and 3 is 6. So we have that first. Now we're going to combine our like bases, our like variable bases. And we would end up with this. Because we have x to the 1 here, that's going to be -5 and -3. It's going to give us a -8. And we have a 1 here, that's going to give us 7. Okay. On the bottom, we have y to the 3 and x to the 6, because 6 minus 3 is 3. All right, and now we can further reduce that, because if we bring that -8 down here, it'll switch to a +8. So that's going to be x to the 14 on the bottom. And we note that the exponent is bigger on top, so we'll bring the smaller exponent up to the top, which would make that a -3. 7 minus 3 is going to be 4, so it'll be y to the 4 on the top and x to the 14 on the bottom. Okay? Easy peasy, y'all can do this. Easy peasy. So we went from here to here, and that's the right answer. All right, so let's talk about some circle relationships. If we know the area of a circle, we can find the diameter of the circle and can find the radius of the circle because it's half the diameter. If we know the circumference of a circle, we can also find the diameter and the radius of the circle. First, let's look at this example problem 2.5. The area of a circle is 12.2 meters. square, excuse me. That's the area. So what is the circumference? All right, so we know the formula for circumference is going to be, well, actually, we were given the area, and we got to find the circumference. So no, the area is pi r squared equals, and this is the area, 12.2 meters square. Okay, well, we don't know the radius yet, but we know what pi is. So we take pi as a factor, and we're going to eliminate pi. We're going to divide both sides by pi, by the value of pi. That's a 2. So we do that. Let me bring up my calculator so y'all can see me do it. So 12.2 divided by 3.14, right? That's going to give us approximately 3.885. We can say 3.89. So r squared is going to be approximately 3.89 meters squared, right? All right, so this is squared. So how do we unsquare this? We use a radical symbol. So r would equal the square root of 3.89 meters square, right? We go all the way across there. So we can do that on the calculator too. We pull this up, and let's do 3.89 square root of, it's going to be 1.97 because this 2 doesn't round up. So it's going to be, the radius is approximately 1.97 meters for the radius. So in order to find the circumference, now we take the radius and apply it to our circumference. And our circumference formula is going to be 2 pi r, right? So we take this number here, 1.97 times 2, and that equals 3.94 times pi. So that's going to be 12.37. So our circumference is 12.37 meters. All right. It's a 9. So that's how we would do that. You undo, you find the area and you back it out by getting pi out of it. We know what pi is. And then we unsquare what's left to get the radius. Then we take the radius and drop it into our circumference formula, and then we end up with our circumference. All right, let's see if we can do that again. Let's clear the page. 2.6. The circumference of a circle is 8 pi. And that's centimeters. So that's the circumference. What is the area? Oh, well, that is just easy peasy. Because we know that the circumference is 2 pi r, right? And if our circumference is 8 pi, well, we can go ahead and divide both sides by pi and get rid of that, right? Cancel that out. So 2r is 8. So we can divide both sides by 2. So our radius is 4. Now we can drop this into our area, and our area is pi r squared. Okay, if r is 4, then 4 times 4 is 16. So 16 pi, and that's centimeters squared, is our area. And that's all we have to do. This is a simplified form. That's the right answer. That was easy peasy. All right, and that's all I have for lesson 2, and I'll see you in lesson 3.